Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and this video is number 5 in a series of lecture videos on complex numbers. Let's continue. Yesterday we talked about writing complex numbers in polar form using Euler's formula, which could be given as z equals r times e to the power I theta, where r is the modulus or the absolute value of the complex number, and theta is the argument or the angle. Now let's go ahead and take a look at these numbers and write them each using Euler's formula. The first one is 2 plus 2i. So let's go ahead and take a look. First of all, we're going to start by plotting this number on the complex plane, which is also called the argand plane. I hope I didn't mispronounce it. So 2 plus 2i basically can be turned into the ordered pair 2, 2, and that will be located right here. Let's go ahead and connect it to the origin with a straight line like this. And then we're going to find two things here, r and theta. That's what you need, because remember, z can be written as r times e to the power I theta. And those are the variables pretty much. So r from the Pythagorean theorem is going to be 2 root 2, because that's the hypotenuse. And theta is going to be pi over 4. Why? Because this triangle is isosceles. Great. So we know r and we know theta, so we have everything we need. Let's go ahead and write it down. Z can be written as 2 root 2 multiplied by e to the power I times pi over 4. Later on, we're going to see why this form is very useful, especially when solving equations or evaluating expressions. Okay, let's take a look at another one. So the next one we're going to look at is 1 minus root 3i. And to be able to do that, again, we're going to start by plotting 1 comma negative root 3. Root 3 is about 1.7 roughly, so you can kind of locate it. 1 is going to be here, and negative root 3 is going to be probably a little less than, I would say, negative 1.75, which is kind of somewhere here. So they are going to be intersecting, seem to be intersecting at this point, and then we can go ahead and connect this to the origin. Start here and connect with a straight line, and there you go. Now in this case, of course, the angle theta is going to start here, right? So we kind of have to think about, okay, what angle are we looking at? Obviously, that's going to be greater than 180 degrees, even greater than 270 degrees. So let's go ahead and find out what that angle is going to be. How do you find it? Well, here's the thing. This is negative root 3, and this is 1. If you know your trigonometric values, this should not be too hard, because what we have here is a 30, 60, 90 triangle. And since this is the longer leg, this is going to be 60 degrees. So the angle we're trying to measure, the positive angle, which is in the counterclockwise direction, is going to be 300 degrees. But you kind of need to write it in radians, and in radians, how do you do that, right? Well, here's the thing. If you know 60 degrees is equivalent to pi over 3, then you can basically just subtract it from 2 pi and write it as 5 pi over 3. Or if you know that 60 is pi over 3, then just multiply by 5 and you get the same answer. In other words, our theta is going to be 5 pi over 3 as measured from the positive x-axis, and r would be the hypotenuse of a 30, 60, 90 triangle. This is root 3 in length, and this is 1. So how would you find the hypotenuse? That would be 2, because it's twice the shorter leg. Therefore, r would be 2. And now we got everything we need. 1 minus root 3i can be written as 2 times e to the power I times 5 pi over 3. Awesome. That's pretty much how you write it in polar form, in the most compact form. Okay, great. Let's take a look at another one. This time we have z equals 4i. To be able to write 4i in polar form, again, we're going to use the first plot it. 4i means 0 plus 4i, so it's equivalent to 0, 4. 0, 4 is located right here. So if we connect it to the origin, which is obviously going to be across the y-axis, right, with a straight line, then that's going to be our number. And as you can see here, r will be 4 because it's just the distance from 0. And theta would be what? Pi over 2, right? Because we're basically on the positive y-axis, making a 90-degree angle with the positive x-axis. So r is equal to 4, theta is pi over 2. How do you put it together? 4i equals 4 times e to the power I times pi over 2. Again, this is going to be helpful later on when we do the different problems, calculations and powers and equations and all that stuff. Okay, so let's continue with other stuff. We're going to talk about a very interesting theorem. Let's go ahead and take a look. Well, I could never pronounce it, but I think it's something like the Moivre. Well, anyways, I prefer to say the Moivre's formula. I think it's French. And the formula basically gives us, when you have a complex number in polar form, you can raise it to the nth power easily. And the way to do that is you take the modulus r, raise it to the nth power, and then you take the argument and just multiply by n, and you're all set. Make sense? And obviously, in the more compact form, this is going to be even easier, and we'll talk about that later. But let's go ahead and take a look at this, how this applies to different situations. So I have cosine pi over 3 plus I sine pi over 3, and I'm going to cube it. So how do you cube it, right? Let's go ahead and take a look. To be able to cube it, basically, first of all, notice that its modulus is 1 because there's no number in front of it. So I can basically just multiply the argument by 3. That's going to give me cosine pi plus I sine pi. And if you want to write this number in standard form, just think about what cosine pi is going to be. Pi is going to be right here, and its cosine is going to be the x value, which is -1. So this is -1, and this is going to be 0. In other words, this number is equivalent to -1 in the complex world. Make sense? Great. Now, this is something to remember. Let's go ahead and take a look at another one. 1 minus I to the 4th power. Now, in order to be able to use the Moivre's formula, we kind of need to put this in polar form first. But you guys probably know this already, right? Let's go ahead and do it quickly. 1 comma -1. My number is going to be located here. And its angle is going to be, notice that pi over 4 short of 2 pi. So if you subtract pi over 4 from 2 pi, you're going to get 7 pi over 4. And the radius, or r, the modulus, is just going to be √2 from Pythagorean theorem. Therefore, I can write this number as √2 times cosine 7 pi over 4 plus I sine 7 pi over 4. And now I'm supposed to raise it to the 4th power. Let's go ahead and do it. How do you do that? You just raise square root of 2 to the 4th power and then multiply the angles by 4. Cosine 7 pi plus I sine 7 pi. But 7 pi is greater than 2 pi. If you subtract multiples of 2 pi from it, you're going to notice that it's actually pi plus 6 pi. 6 pi is 0, in other words. And this is going to be a 4 times cosine pi plus I sine pi. And since cosine pi is -1, we can basically write this as -4. In other words, if you raise this number to the 4th power, you get -4, which is kind of interesting, right? And this is the end of this video. Don't forget to subscribe, hit the notification bell, and stay tuned for upcoming videos. See you in the next episode. Bye.